Performance and Analytics Seminar. Really happy to see you all here today. For those of you who remember, we had run this seminar for quite a few years in the 2000s, and then all of us who were organizing it got really busy, and I moved out of the country. So I've come back, and really happy to be back in Toronto again. Felt there was a need to have this kind of seminar, and I think the number of people who come out today really reinforces that. So what we're planning to do with this seminar series is to have it be a chance to network with your peers and with companies who are hiring analytics people, or with academics who are running analytics programs. So there's going to be a variety of different people here. I encourage you to introduce yourself to people. And the other idea is to provide educational opportunities. So people will be giving talks on new techniques that they're using, case studies, and things that should be interesting and useful for you to take back to your work. We wanted to kick it off today with something a bit more general, so that's hence the topic, the future of data science, to just get the conversation started. So thanks again for coming. I'd like to really thank the sponsors that we have for this organization. So I'm going to let each of our sponsors give a little bit of an overview. So I'd like to start with Fernando, who's going to talk about the SORA. I'm going to leave it to him to tell you what SORA stands for. And then we also have a few other sponsors who are going to speak as well. So thank you.
Thank you, Alison. I'm Fernando Camacho. I'm president of the American Statistical Association side of the Southern Ontario Regional Association. The association has a few number of years in place, and it's a joint committee of the American Statistical Association and the Statistical Society of Canada. And here in Toronto, we also have a very close relationship with TABA, the Toronto Area Biostatistical Association. So we organize also seminars in statistics for people more interested in the medical side as rather than the financial side that these seminars are focused to. So I'd certainly like to invite you to become members of SORA. And it's very easy to become a member. If you are a student, it's free. If you are professional, it's only $10 per year. And you can find all the information for joining SORA in the website. I think you can see the website in this page. And you need to click in the SORA membership application, and you get everything there that you will need for that. And before I leave, I certainly like to express my sincere gratitude to Alison, first for coming back, and second for all the energy you have put together to organize this seminar. Thank you very much, Alison.
Hi, my name is Alison. I'm your host here at RBC, and Alison and I actually go back a little ways, having worked together. We had a bet over whether anyone would sit in the front row, and she said yes, and I said no, so I'm not going to be a SORA loser. Okay, there you go. All right, so in addition to jokes, here at RBC, we have a program called Future Makers, and it's RBC's support of tech communities like yours. So we have a little booth outside. Please help yourself to some swag, but also sign up for our email list, because we host many events, and one of the events that's coming up is on product management on February 7th, and if you'd like a discounted ticket, be sure to enter your email. We have discounted tickets to things every month. And finally, RBC is hiring folks like you. In fact, I did a little search on our website, and we have 276 jobs right now that have some sort of data statistics in it around the world. So London, New York, it's all possible. Most of them are here in Toronto, though, so please consider us for that. And thank you, and enjoy the panel today. And I'll introduce the other sponsor for Environics.
Thank you, Alison and Alison. Good afternoon, everybody. My name is Eric Kai. I used to organize this seminar series 5 years ago when Alison was in Los Angeles, so it's great to see some familiar faces, and it's great to see some new faces. You may know me from my blog, The Chemical Statistician, where I write technical tutorials on statistics and chemistry and also career advice. I am also active on Twitter and LinkedIn, and just last year I started a new talk show called The Central Equilibrium, in which I interview guests from maths, science, or economics to talk about technical topics, and they teach me new concepts by writing formulas, equations, diagrams, or graphs on a whiteboard. So I'm very excited about my new talk show, but today I'm speaking on behalf of my company, which is Environics Analytics. We are a premier marketing analytics company based in Toronto, active in Canada and in the United States. We provide data products, consulting services, and software to help businesses, governmental organizations, and nonprofit organizations to learn more about the audiences whom they serve and to make better business decisions. We were named one of Canada's fastest growing companies by Profit Magazine, and we are hiring data scientists. So if you're interested in learning more about our company or applying to work for our company, we have an information sheet just outside at the information table and also at the registration table. And if you're also interested, you can come to talk to me afterwards, and I'd be happy to tell you more about our company and answer your questions. So thank you so much, Alison, for allowing our company to sponsor this event.
Thank you. So now I would like to invite our panelists up, and also Emma Warlow, who is a statistician who runs an analytics consultancy in Toronto, has kindly volunteered to say a few words to sort of start the conversation and give some food for thought that our panelists will then be able to respond to. So if people want to come on up. And then what I'm going to do is, after Emma's spoken, we're going to have everyone introduce themselves, and we will start our panel discussion. Sorry, you don't need to see my kids. Sorry about that.
Thanks, Alison. Alison asked me to start a few words off by just talking a little bit about the future of data science. And so I've been thinking a little bit about it over the last few weeks and what I think the future of data science is. And I certainly don't have all the answers. I don't profess to be an expert in all the answers. I do run a small consulting firm where we help companies understand their customers better through analytics and better use of their data. We have a practice that's involved being partner to our clients and coming in along, working alongside them to help grow their capabilities. And so as I started thinking about the future of data science, one of the things that occurred to me is that this Christmas I was gifted a small piece of electronics that was bought apparently for under $50 on Good Friday, or on Black Friday. And it occurred to me that the future of data science is kind of already here, in that we now have a natural language processing tool that sits on my kitchen counter that can answer a lot of the questions that I have about anything I want to have. It can also spy on my kids, which they didn't realize, and they started asking a bunch of questions, which I then got fed through the app. And I was told what kind of questions they were asking me, but they were asking Alexa, which was kind of fun. But you know, this is something that seemed to sort of almost come out of nowhere in some ways, and that we went from trying to get answers and using data in thinking about text analytics and text mining was something that was kind of a bit of a foreign world, and all of a sudden now we're at a place where we can talk to a machine. It can understand people who talk as fast as me, and that's pretty impressive. And so it occurred to me that in some ways the future of data science is already here. But obviously, the other thing I think about is it didn't really come out of nowhere. We've been talking about data science in different words and different terms and machine learning for many, many, many years. I'm older than some people in this room, and I have been hearing about neural networks and artificial intelligence for as long as I can remember. And what's really changed, obviously, is that now we have better computing power, we have more data, and we have the ability to store and access more data. We have new algorithms, and suddenly now it's here. And as I think about what that means for data scientists, and some of you in this room, I think we think about the fact that in many ways it's given us a huge advantage. So when I look back in early days of my career, when I was building regression models and things like that, I used to have to wade through manually a whole bunch of SAS output in order to figure out some of the relationships between variables, and it took a long time, and it was really time consuming. And now these things are a lot of this variable selection is happening in real time and very quickly. And that's a real change, and that's really made the job easier in some ways, and the output more, faster and able to get things. We've also now, when we look at things, when we used to make predictions, it was a big deal to build a model and do a prediction. And now we think about things that are happening every day when I turn on my television. There's predictions being made all the time, for millions of different users predicting millions of different things, what would I like to watch. And these aren't my predictions, just for the record. But, there's things have happened so quickly and so much has changed, and the job has changed dramatically. So naturally it starts people asking questions around, well, what would the future be for data scientists? Because we've talked about the fact that for people who drive for a living, perhaps in not too many years, self-driving cars will take a lot of those jobs away. We've listened to people talk about drones delivering packages and pizzas and all these kind of things. And we've talked even about medical science being, some of the work being replaced by robotics and those kinds of things. And it makes everybody think about what the future of work is. And I think, it's one of those things that we start to think, well, machines just do everything. I heard a panel speak recently on the medical side, talking about the fact that one of the fears some of the surgeons that were being interviewed had was that as we get better and better with robotic surgery, in some ways that's fantastic. It allows you to deliver surgery in remote communities and things like that would have been impossible in the past. But it also raises an issue that what if eventually, if so much of it's being delivered that way, will there be fewer and fewer people who actually know how to do it if something goes wrong, who actually have enough experience to be able to apply? And I think about the same thing in analytics. The more and more that's taken away, a lot of what people who are really good at this field is because they've seen a lot of this stuff before. They've tried different things, some things have worked, some things haven't. So I think there'll still be a role for people who have experience and are building experience. And as we think about the algorithms, they're not perfect. And we know they're not perfect, and there's a few examples I have of some ways that the algorithms aren't always perfect. Use that example of a 20-minute ride in Toronto costing someone 18 grand on Uber. Right? Something wrong with the algorithm that made that happen. I get that search pricing exists, but from a public relations point of view and from a customer experience point of view, it's probably not an ideal situation if the algorithm is allowed to do that. As recently as yesterday, there was the ability for human beings to interfere with algorithms. So Yelp has an algorithm that figures out how many stars somebody has. And Trump's hotel yesterday ended up with a 2-star rating on Yelp. I'm sure it's since been corrected, but because so many people went in and wrote, this is a shithole, excuse my language. So I think we have an opportunity to see that algorithms can be great, but algorithms have, we also have to figure out how as human beings we still have some interface and intervening with them. I think so. I think the future for data science is great. I certainly think the short-term future is fantastic. There's every prediction, everybody out there talks about the fact that the number of data science jobs is growing by leaps and bounds. I think one of the things that most of us in the industry realize is that not all companies are Google and Netflix, and there's a lot of work still to be done. I don't think very many companies have cracked this nut yet. Not many companies have got everything working together. So there's a lot of work in this field. This is a great time to be in this industry. And for those of you who have heard a few students in the room, you're in a great place to be. I do think things will evolve though over the next number of years. I think we're going to start to see sort of two different streams of people, and we're probably already seeing a little bit of that already. I think we'll see that there will be a growth in the number of people who have deep technical knowledge, that it will be required in certain jobs to have really deep technical knowledge, and a lot more than, for example, I needed to have when I got in this profession. Really deep understanding of how computing works, how engineering works, those kind of things. But I also think there'll be huge growth, and it's not just me that thinks this is something that other people are talking about. There'll be growth and a real need for more people who can bridge that gap between that deep technical data science and the business. And Gardner's termed these citizen data scientists, and I think that's an area where I think all of us should continue to think about, is that the role we want to play? I don't think everybody has to necessarily become a deep machine learning expert, but there's a real role for people who understand the business, who understand the business problems, understand how to frame those business problems, and I think that's one of the areas we're going to see the most growth in the data science field in the next little while. So I'm bored about this, it's not a really good diagram, but the idea being that I think for a little while we're going to see higher and higher demand for more and more technical skills. But over the long run, I think fewer and fewer people will have to have those. It'll be a real specialized group that have those really deep technical skills, and we'll see more and more people who have to have a good understanding of how do I tell stories, how do I understand what the business needs? How do I interpret and create insights from the business problem? And those are skills that I think haven't changed and won't change in data science. I'm looking forward to hearing what everybody else thinks. My final prediction about data science is, if I can say one thing, I'm sure of this one, which is I don't think we'll be called data scientists in 20 years, because every single title I've ever had in this industry has changed 1,000 times. I've been called everything under the sun, and I suspect many of you have had different titles already, and I can pretty much guarantee that data science will be replaced by something else, and it won't take 20 years. So that's all I was going to say before we start.
Thank you.
Thank you.
Well, thank you very much, Emma. Very thought-provoking. I don't know if I can share with you, my first job title actually out of school was mathematician, which I've really not sort of come close to since, but I agree.
I was a modeling analyst, which always sounded like the Ford modeling company should come and pick me up, but they never did at 5
Actually, maybe I'll add that. I'm going to ask the panelists to introduce themselves, and as part of that, I want you to tell me your most interesting job title in your time as an analytics person. So you have a few seconds to think about that. So I'm going to ask Emma, and I think we might be one microphone short, but maybe to give a bit of your background as well. Oh.
As you already heard, I'm Emma Warlow, and I came into the field through math and stats, like many of you. I started working for a small consulting firm after I did my master's in management science, which was a degree in operations research and statistics. And then I went into financial services and worked for a number of years for both Bank of Montreal and then Royal Bank. About 18 years ago, I started DIG. And my most interesting title, I think, would probably be modeling analyst, because it always made everyone I knew laugh, as someone who's 5'2". My other probably informal term is always that I was always called the math geek, so I stuck with that one too.
Hi everyone, I'm Özge Yolu. I'm leading the data and AI team at Microsoft Canada, working with 11 data architects and data scientists in my team. I've been with Microsoft for about 2 years. Actually, it's 2 years today. I was just thinking about it. And before that, I ran a startup in predictive data analytics space for 3 years. And before that, I was a PhD student in computer science focusing on machine learning. So I've done a little bit of everything. And because I've done a little bit of everything, I don't know if I really had any interesting titles. You know, I was like startup co-founder and a student, and you know, so I don't know. I really don't have one, I think.
Cool.
Okay, my turn. My name is Jenny Baboğlu, and I started data science 3 years ago. This is my 3rd year in data science. Before, I was an associate professor in math, and my expertise was in nonlinear partial differential equations. There you go, okay? And I'm an all-time student. So what I like in data science is actually how I apply math there and how I can use the algorithms in a way that we can really get the output and read the stories and come up with predictions and decisions and learn from the algorithms and data science. This is what data science is for me. And now I'm working as a senior data analytics associate in Rice University. Also, since I have that 20 years of math, so I'm a senior researcher in data science lab, again in Rice University.
Hi everyone. My name is Sarah. So I didn't come through data science through the traditional field. I was actually in science, and then I went into finance, and I went to product, and then I went into data. So I'm sure we have some questions around that. We can talk about that later. And I was in the financial industry for about 8 years prior to coming over to retail. So now working at Shopify, leading a data science team for our product groups.
I'm Neil Bartlett. So I guess I started my data career, we were doing a lot of stochastic differential equations at a company I was at called Algorithmics. I was a senior executive there. My role was always on the very technical side. I was the CTO. We got purchased by IBM, and I then became the CTO for what was Watson Analytics for a couple of years. Then I decided to sort of leverage the fact I'd worked with banks for about 30 years, and I joined Scotia about a year ago, and then I came to work here at RBC about 6 months ago. I run the what we now call the data and analytics team, which has the nice euphemism of DNA. So, because we are the core of the foundational core of RBC. So I think it's really interesting because of that fact that RBC's let us call ourselves DNA, and they realise how central we are to everything. And I think that makes it my most interesting title I've had, which is the manager of DNA. It makes me feel pretty special.
Excellent, thank you. So I know the topic of this is the future of data science, but I'm also have an academic background and did research. And I think before you start talking about extending something, you have to talk about what it is. And I do feel that data science is perhaps one of the more poorly defined subject areas out there. So I'm going to ask each of the panelists to tell me in their minds, what is data science?
The best description I heard recently was somebody described data science as like a 5-year-old child who's always asking why. And I thought that was a great description. In my mind, data science at the moment is, to Alison's point, kind of a term that's used by a lot of people to mean a lot of different things. We have a lot of people who were traditionally statisticians are calling them data scientists. We have other people who were programmers who are calling themselves data scientists, engineers. And I think at the moment it's still a bit of a confusing term. I heard somebody else recently say that a data scientist is any data analyst who lives in San Francisco. So I think there's a lot of, there's still a lot of confusion. I think at the core, it's probably taking a little bit of all those disciplines and meshing them together and recognizing that in order to truly leverage this science, like any other science, you have to understand a lot of different types of work and try to figure out how they all mesh together. My answer. And I just remember my best title is my current title, which is Chief Digger.
Yeah, it is. I don't think there's a very clear definition of data science, but what I usually or recently like to point out to everyone is the second word in that term, science. Okay? I think we usually forget the science in data science. I think data science is about, it's like any science. You have a hypothesis and you just go experiment with it. Usually you don't know what you're going to get out of it. But I think however we're doing that data science process, I think that's the most important part that we have to keep in mind. This is a science. And you have to ask the right questions to the right data to be able to get the right answers. So I think that would be my, not necessarily explaining what data science is, but that's one of the things that we keep in mind when we talk about data science.
Adding one more thing to this, it is really multidisciplinary. So we have math, statistics, computer science all combined, and it is something like, as a mathematician, for example, I cannot say that, oh, I don't understand this algorithm or I cannot understand this coding. I should understand all. So in our data science lab, we have different groups, and I'm leading the projects as well. So in our groups, we need all of them. We need computer science people and math people, statistics people, engineering is still there, okay, so all of them. And the thing is that we can be very expertise in one of the things, but still overall, we have to know all of those. And it is really multidisciplinary.
So maybe to add something that has been said, it's very much, for data science, there's definitely the technical aspect, but there's definitely a huge soft aspect that Emma was talking about earlier. How do we tell and help our business and product understand what this insight means? And how do we actually apply it? And I think that's going to be a big piece in our data science as well. And actually one thing that I really love about data science is like 10 years ago, we don't have data science degrees or designations, And one of the big things I love about this field is just how diverse. There's a lot of different people coming in with different backgrounds, with different thoughts and leadership. So it's just been a really, really great experience being part of this journey on growing data science.
Yes. Yeah, no, I completely agree with everybody else. But the one thing I would add is that I think the real thing is it's about how do you extract value from data, and not just value, but business value. And that's the key fundamental, and it's not just about can you extract value, it's actually extracting value, and how do you deliver something to an organisation that's of value to that organisation, which is founded on data. And so, you know, a lot of stuff that happens, if it stays in someone's head or just on a piece of paper, it's not good enough. It's really about how do you change your business, and how do you make your business actually foundationally work better because of data. I think that's a key aspect.
Well, actually, that's a good segue into my next question. I'm going to ask for a volunteer or volunteers for this, someone who feels they have a good story, but does anyone have a story to share of somewhere where they've used data to have substantial business impact? Because I know that's what really fires us up. Any volunteers?
I can go. I think the space is still, in many cases, in its infancy in businesses, right? Like being able to create that business value, and not because that data science can't do it. It's usually the businesses don't know how to create that value. But the main industry that I'm seeing these days, and we work with many different verticals like financial services, government, healthcare, manufacturing, telco, retail. But the main place that I see that we're adding really fast value is manufacturing. And the main reason for that is manufacturing companies are actually able to see the return on value, return on investment with these projects right away. Like we create predictive maintenance case studies and use cases with manufacturing companies constantly in the last year, and they're loving it because the moment they operationalize this solution, they're seeing the value of that solution right away.
I can add my experience in data science stuff. Each project is a case study for us, and we have collaboration with St. Mike's Hospital, some insurance companies, and financial data, I would say, TMX, and Toronto Police Services, and all of these projects are case studies, and the results that we are getting are used immediately. So, for example, collisions it was a data set which was covering all collisions for the last 10 years in GTA, and we are doing predictions on that. But the main research question is not always the prediction. So when we have a data set, we should answer small questions first, right? Instead of going to the big question, okay, I'm predicting this, predicting that. Instead of going there, we should understand the data and the patterns there and come up with stories. What can we learn about these data sets? So each project that we touch in university, we have collaborators, and the data set is coming from real-world data set, and each one is a case study that is really used at the end of the project. So some projects are for 3 months, some of them for 6 months, some of them are for 2 years, but at the end, those are all publicly used.
Maybe from a retail perspective, and for those of you who don't know Shopify, it's a e-commerce platform for small, medium, enterprise-sized businesses. And one of the really cool things with Shopify is that we've been around for about 10 years, and we've actually had like millions of merchants on our platform, and we've collected a lot of that data. And now what we're doing right now is kind of like, how can we use this data to help our merchants succeed? And like with our merchants, we know that they value time, they value being successful on the platform. And one of the big pieces that we're doing is actually one thing we rolled out pretty recently is a fraud algorithms. So pretty much helping our merchants save time by telling them like, hey, this purchase order could potentially be fraudulent. So maybe you want to be careful when you want to fulfill this. So kind of like this is one of the applications that we've used ML algorithms to help merchants succeed and improve their time.
I guess that I like those projects that really change people's behaviour and help them out a lot, as well as adding business value. And a lot of those tend to revolve around the sort of natural language processing because they tend to integrate more. And I really like those projects that have natural language processing, but then feedback loops in them, so they continue to get better and better and improved. You know, one project that we've actually done at RBC, and actually we've ironically done a very similar project at Scotia, is the notion that internally there are lots of calls made to the call centres, because the call centres are the only places that know all of the processes that the bank follows. And so most banks have about 1 million calls to their call centre, which are just completely from internal employees trying to understand a process. And it's because all of the documentation around those processes is so poor and difficult to search. And if you put a Google-like algorithm on them, you won't get anywhere. But if you take a more machine learning approach around what needs to happen, and more NLP approach with some feedback loops, you can radically improve people's lives and reduce the number of calls down to very low volumes. That's the type of project I like a lot, because it's really, you can see people's behaviour change and so forth. Yeah.
Nice.
All our projects are business-focused projects, and we always, try to make sure all of them add business value. So I don't have one specific one, but maybe I'll tell the story of one that is kind of untraditional, because it wasn't really a great data science project, but it was something that kind of we stumbled upon by accident. So we were asked by a client to help them isolate the customers that they were losing through a problem they had. They'd identified a problem with retention. And so they asked us to analyze and come up with a plan to help them target the people that they were losing. And what we went into it thinking we were going to find sort of just, an interesting profile of those people that were leaving. And as we dug further and further into the data, it took us a number of different avenues, including understanding how their website was working and that it wasn't working that they thought it was. And what we ended up discovering was that they were literally about to launch a huge retention campaign. It was going to cost them a lot of money to try to wrap their arms around customers. And what we actually discovered was that the problem wasn't so much in how they were, or who the customers they were losing. It was actually a problem in the way they were measuring retention. And in fact, the real core of the problem was to do with their acquisition strategy. And so they actually redirected all the money they were going to be spending on retention and changed acquisition and had a big business benefit. So it was something that was not, some incredibly insightful data science, but it was just using the data to really add business value and recognizing that sometimes that's the pragmatic thing, is just to add business value along the way.
Great. So a number of you are in the position, or sometimes in the position of recruiting into data science type roles. What would you say are the main types of backgrounds that you're looking for these days? Yes, we'll start at that end.
Yeah, sure, I'll start. I mean, obviously, there's the technical requirements, but I think the point that was made earlier that it's this bridging role that you can understand both the business side and the data side is the most important, one of the most important things. Another aspect is, what I would say is, how do you ensure that you're really focused on extracting value easily? So you need to be very familiar with agile style processes, because inevitably, the point you were making earlier is like, I just found this thing for you, this is really valuable, let's do it now. That's the sort of the way of thinking, I think, that tends to get most value. So if you're in an interview, for example, putting things in those terms of how you did projects and how those projects were extracting value cleanly, because what I see a lot of is, I've got a great idea and it's a big algorithm or a big thought and it's going to take me a year to do it. That better be a very, very, very valuable thing. Otherwise, it's not a valuable use of time. So it's really how do you understand the business value in context, so that you can really apply data science in a manner of extracting value. And the big ideas are great, and we definitely need them. But also how you approach the evolution of an idea is very important. So it's that understanding, that sort of business sense, I think, is very critical.
Yeah, 100% agree. And the whole communication piece, it's around, great, I got this insight, I can add this business value, but now how do I communicate it? For me, communication is definitely one of the key components. The technical piece, as you said, that's always going to be important, but then for me, it's also a passion, because data science is a growing field, and it's always going to continue changing, and there's always going to be new things coming up. So So I really, like for me, when I look for candidates, like they have a passion to learn and they want to learn, they're doing this on their own time. To me, it's one of the really, really great things that I'm looking for candidates.
And my turn. So as an academician, I'm not hiring, but we choose students, right? So when for our projects, we work with master's and PhD students, and we have a lot of applications in data science. You may be aware of many applications. And in the projects, we need some junior data scientists, so any certificate program is okay for us. For example, some courses from data science certificate program, if the students have taken those, they can work with us in the projects. But in some projects, we need some advanced knowledge, so we can somehow generalize an algorithm that really we need the core ideas, and somehow the person there, the student there, should be somehow in a case to be the function in the algorithm, right? So how that algorithm is working. Okay, what measure is it using? Is it a distance measure, or is it a similarity measure? What is it doing? So that we can maybe generalize algorithms or come up with new algorithms. So in that manner, we need some PhD students and advanced students, and master program is helping us with that. We have a master program in Rice University, Data Science Master's Program, and that is the only part-time program that those students are more, let's say, I may say that they are more digging in math and statistics and the computer science background. So this is how we are, constructing our teams in data science lab.
I actually just finalized hiring for my team, and it was painful to go through that process. And in my case, mainly because I think I was looking for those like unicorns who had very technical, deep technical background. Like I have PhDs in machine learning, masters, or 10 years of experience in this field with communication skills. Like it's definitely important for us as well. And mainly in our case, like because we work with our customers directly, we should be able to, and I encourage my team to do this, like when we're talking with the customer and when they ask us to do something, sometimes I actually say no, because it doesn't make sense, right? Like I got asked, we want to build this was actually a bank in Canada, we want to build a machine learning platform. And I'm like, that sounds amazing, gets me excited. And then it's like, here's my 3-year plan and budget. I'm like, yeah, sorry, I can't help you with that. How about we plan for the next 6 to 12 months and then we'll go from there, right? So to be able to have those kind of conversations and explain on why it doesn't make sense to do this, or if it's a very specific project, like, yeah, sorry, I can't help you with that because what you want doesn't make sense. To be able to say that is really important, obviously in a nice way. The other thing, I always look for Python or R skills. If you don't know Python or R, I can't really trust that you are a good data scientist. And this is very personal. A lot of people might agree or not with that, but that's my thought.
Yeah, I think a lot of the same things people have talked about, for sure. I look for people with passion, with storytelling abilities, with an innate sense of curiosity. I think is one of the things that I'm most interested in. I want people who want to learn, who want to look for new ideas, try to ask good questions, who aren't willing just to take the status quo, to your point. Like, I think those are all really key. I'm less focused on technical skills, partly because our organization, we go in and partner with clients and work on client sites, and we use whatever tools they're working with. And so I need them to be able to learn new technology, and I never know what that's going to be for sure. I know what some of the things are for sure, Python and R, and those things are key things. But I also look for people who have been interested in learning new things and have tried new tools and are willing to, have got the basic programming skills to be able to learn something new. That's more critical.
Well, that actually flows in nicely to the next question, which was really about, if I think back 15 years and someone said to me, I want a career in analytics, I used to say, you need to learn SAS. You need to go and figure out how to code in that. I feel like now that world has exploded in terms of different skills, and curious to see, are there specific tools that you guys look to have people already have familiarity with?
You know, I'm going to go against the grain here and say I don't think SAS has gone away yet. I see a lot of need for SAS skills still in a lot of the jobs that we do, so I don't necessarily think it's not a wasted skill to have, because I do see a lot of companies still very heavily invested in SAS, and some looking to invest further in the future. I agree that R and Python are good. I think data visualization tools, I think any ability to use the various data visualization tools allow you to help tell the stories better, and so I think those are really important. I still think a lot of people need SQL skills, because a lot of the tools that we use today are based on the basics of SQL, even in NoSQL environments. I think there's still a lot of knowing how to use SQL is a valuable skill still in my opinion.
I would say Python and R. Those would be that would be the baseline for me. Let's say. And other than that, I honestly don't care. Because if you're a good data scientist, you should already know that you have to pick up a new tool or technology every other day, because you have to have that curiosity. You never know where the next best tool is going to come from. You might be doing SQL today, next day it might be Hadoop, and the next day it's NoSQL, Mongo. It really doesn't matter. But Python and R, if you got that, whatever you got on top of it, I'm good with it.
So in our projects, we mostly use R because the certificate program in Ryerson and the master's program in Ryerson all are using R. That's why mostly it is R. But we are okay with Python or R. All of the members in the data science lab can do both. But it is not enough for us, because we're really working with big data. So it's really millions of rows, and it can be structured, unstructured, the things that we're working. So that's why SQL, NoSQL, depending on the structure or unstructured data, and also Hadoop, Peak, Hive, all of them are needed for us, and each one of them is a baseline requirement. So on top of the programming languages, we need tools for big data as well.
It's been said already, so I'll pass it over to you.
Yeah, I mean, obviously I agree with the language and so on. I guess if you're going to, depends what sort of data science you want to do, but if you want to do, say, deep learning, then I think Keras and TensorFlow are pretty well essential, notwithstanding what Microsoft may say. But yeah, so no, I agree, Python and R would be absolutely necessary.
Great. And actually, just mentioning the big data tools, to me, the term data scientist is sort of intrinsic with big data. And then I go out there and I work in consulting problems, and a lot of the data, at least to me, doesn't actually look all that big. What do you think? Do you think for it to really be a data science problem, it has to be big data, or is that not the key?
No, I think that the real thing is extracting value from it, right? I mean, and I think that with data science versus an analyst, I mean, it may be a small set of data, but if you can extract more value from it using a new technique, then that's the value you bring to the table. I mean, some very valuable projects actually don't use very much data at all. So I think there is a misunderstanding that big data and data science have to be joined at the hip. But I think a lot of valuable things happen with smaller sets of data. And it's especially valuable when you add a new small set of data to a larger set. And it can be like a puzzle piece, right? So it's really about how do you collect that data.
Yeah, I would say, kind of touching to Neil's comment there, variety is most of the times is more important than the volume, I find, in data science. I mean, there are definitely big data cases, for sure, but is it a must? Not really, I agree on that.
So for data, it should give us meaning, and we should, of course, answer some research questions from that. But even to come up with a meaning, or to come up with an inference from the data, it was also technical, actually. So I know that communication with the domain experts or the domain collectors, data collectors are important, but it is still technical. So if you really do your descriptive data analytics and then exploratory data analysis and then go to modeling, so if you really go to each and every step in detail and do your science there, you come up with stories, you come up with inferences, and you come up with conclusions. It's not something that intuition is there as a science, but it is really very technical. And data, right, to come up with stories, we don't need big data. The big data definition comes from the volume, velocity, and variety. Variety is the structure, right? It can be some text, pictures, videos in your data set. So if you have videos, even 100 rows can be a big data for you.
Great. I guess one of the questions, and it's a question actually I was asked on a panel recently, and I thought it was kind of an interesting thought starter. I'm going to ask each one of you to answer it, and that is, you're talking to someone, if you're talking to someone at the beginning of their career, think about talking to yourself at the beginning of your career. What's the one piece of advice you would give yourself knowing what you know now about careers in analytics? I'll give you a second to think. Does anyone have one off the top of their head?
I'll say be curious. That's probably the thing, and like your 5-year-old example, asking the why question, right? Most of the times, I find the most fun thing about our jobs is actually looking at problems from different perspectives. I love it when I read a story about, I don't know, how Uber is using our face detection API, and in my head, and when I work with banks, I'm like, oh, can I use this for ATM fraud detection? Like I just love that part of like taking one thing and trying to apply it to something else, and now you're solving a totally different problem. And to me, that would be one of the main things.
Yeah, one thing I would say is there's a little bit of confusion sometimes amongst data scientists. I think one of the confusion points is that data is just data. And to a certain extent it's true, and actually as Oski is saying, you can cross-pollinate ideas from different domains quite nicely. But I think real value comes when you dig in deep on a business, when you learn a business, and you learn the intricacies of that business, and then you apply data science. So a lot of times data science will sort of skim the surface of the business. And one of the problems there is that the business people don't get really excited about some of the ideas that come out of that. So I think one thing I would encourage you to do is, at least plough the field of a particular business area a fair bit, rather than jumping around, because I think you can add a lot more value. And so if you pick an interest and then find a business thing that you really feel strongly about, then I think there's a lot of value in that.
I guess from a suggestion, or if I were to start off, one thing I think I would actually talk to a lot more professionals in this field as well. I think you can learn a lot from what they have done, and actually a lot of people get to data science in different ways. Like for me, for instance, I didn't come out with a math or stats degree. I was actually an accountant, went into finance, and I actually had a lot of conversations with a lot of individuals, and I was very lucky to have people be open to talking about their career path, how they've gotten there, and that was actually a lot of things that I've learned and actually kind of carried with me to continue growing in the area that I would like to grow in. So I would definitely encourage, for those who are interested in this field, who is not in this field, to talk to these people and get more insights.
I would say a little more communicating with more people, getting in touch with more people, and show your work. That is what I was missing. I was someone who wasn't showing my work that much, so I was reading, learning, but show your work is really important. With presentations, with visualizations, right? So it's not always the technical thing, but to show that technical thing in a way that everybody will be interested, and it should be in a way that each and every one of us who is listening your project or your outcome will be interested, so will be in the work. So the things that I'm working with, I'm leading really different projects. So health data is so much different from a health financial data, right? It's so much different with the police data. And another one was for newspaper, Globe and Mail. So those data sets are so different, business perspective are so different, and I was a little shy to show my work when I was younger. So I think this is something that we should, for young scientists, let's say, I can say.
Yeah, actually, I'd just like to add a point to that, because I think that doing and doing something is probably one of the most important things, right? If you don't practice it and do it, then you're not doing it. And I think a lot of people have a lot of good stuff written, sort of good at academics, but they're not used to actually doing it. And I think that's one thing to practice is actually doing data science.
I wanted to piggyback on something that Neil talked about around the idea of really getting to know the business. I think one of the things that I would say is don't believe our own press a little bit. So as scientists or as people who come out of degrees in math and stats, we're used to being the smartest people in the room. We're used to being pretty smart and thinking we know a lot. And we do know a lot, and no question, I'm sure everyone in this room is very smart. I think, though, that one of the things that I think a lot of young data scientists make the mistake of thinking they know more than the domain experts and they understand the business better. Really, I think if I can give anyone any advice, stop and listen, ask a lot of questions, think about what the business is going to do with the outcome, how are they going to use it. I will always remember, as long as I live, an early experience I had with a woman who came into our team from, we were working in banking at the time, and she came in from a branch. And she was a woman near retirement, and we sort of all thought, what's she going to add to our super smart team of modelers? We've done all this great work. And so in one of her first meetings, we presented the results of we'd done a bunch of models that were going to predict, sort of give them all great leads for the branch. This was many years ago. And we all sort of jumped up and showed all our work, and she looked at us and she said, do you know how a branch works? They don't have any time to follow up on any of those leads. And our balloon was a little bit deflated, but if there was a piece of advice I learned along the way, it's just stop and listen to the domain experts and recognize they have another expertise that's different than yours, but it's just as important.
Great. Does that everyone do that? Okay. Well, thank you so much, everyone. I think at this point, I did promise that I would let the room ask a few questions. So if there's a few people who have some questions for the panelists, this gentleman here, you can come up if you want. Oh, you're loud? Okay, go ahead.
So since the topic is future of data science, I have a question about future of data scientists. So what is the career growth path for data scientists in your opinion? Because that's a question that I'm struggling with these days. My son was thinking about what I want to be next. So I would love to hear your thoughts on that.
Could you please repeat the question?
Yeah, the question is, what is the future of a data scientist? What is the next step and the next role that you would take? Right, I think that's really the question. I think the first thing goes back to the graph we saw earlier. I mean, I genuinely believe that algorithms are being commoditized very rapidly. Machine learning itself will choose your algorithm pretty effectively. I mean, you've got hyperparameterization already from AWS and stuff like that. So, I think there is, the idea that you're going to go and craft a model, I think is becoming, that's very new, I think is becoming less and less true. And I think you've seen, like a bunch of new theories in the last year or so, in the last few months, that are becoming very generalized, and there are more general algorithms coming up. So I think the future is not really about constructing those algorithms so much. It's really about working with businesses to really help them re-engineer their business models and business goals. That's, I think, the future. So it's tending more away from technology and more into the business view. That's what I think one direction everyone's going to take. It's becoming more business savvy and more capable of helping a business out.
Let me add a few comments, if I can. So machine learning algorithms will be there, and AI is of course there. You can So for example, driverless cars, immediately you go to AI or some games. And reinforcement learning is the one that we should really focus on, and deep learning, data mining will be there as well, and also recommender systems. I think that is also something that, whatever we are using in the phones, whenever we click something, we are in a system, so those will be related to the social media as well. So those will be still there, and that is somehow the future of data science. Machine learning, AI, deep learning will be there.
Although I must say I'm often amazed when I'm consulting how many problems can get solved with a crosstab that nobody thought to actually do before. Like just basics of looking at data and looking for patterns. It's a bit of a
We
spectrum.
always talk about pragmatism as being one of the values of our company because of exactly that. Often the quick answer is the right answer, and it's okay.
Yeah.
Just to quickly add on, I'm a huge champion of data literacy, helping our business actually be able to understand the data and even like grasping the data to empower them, right? Like the last thing we want is for our team to become bottlenecks. And it's like, how do we build the data assets in a way that they can consume it in an easy to understand fashion? So there's always going to be roles for us, whether it be doing very heavy algorithms or really helping our business grow in that aspect as well.
I think there's still going to be a lot of roles for a long time for people who are comfortable with data. Like, there's very few organizations today who are really doing all of the really exciting things we read about. The articles we read about in Harvard Business Review and Forbes are few and far between in terms of the companies that are doing those. There is a lot of work still for people who are comfortable around data, who are willing to roll up their sleeves and figure out how to get data to sing, how to get it to talk to each other, to put data sets together. I don't think you should worry about your career in data science. You've got a lot of years before it's something that you would think is going away.
Yeah, I have a question about, maybe I'm talking too loud. Coming from an academic background, a lot of the textbook I see really, they attempt to divide analytics into, your descriptive analytics and then your prediction, and then more structural, prescriptive analytics. And so I've heard a lot of talk around prediction, algorithms, and visualization. But I'm wondering, what is the panel's thoughts on that that third category and where that is? Because I often don't hear it as much in the conversation, and I'm wondering, is it because it's coming from a different discipline area, or it just doesn't, I'm thinking of like the Monte Carlos, the optimization, the queuing models, and more structural type analytics than discovery type analysis.
Yeah, I mean, obviously as a bank, we use a fair bit of sort of Monte Carlo in our risk department and so forth, and we really tend to combine those things. I mean, so one of the projects we just did recently actually was a combination of traditional optimization techniques and machine learning. I think the reason we haven't spoken about it is it's not going away. It's been there a long while, and I think it's a very well-ploughed field in many ways. Are you going to use like a hidden Markov chain to discover seasonality, or are you going to run a machine learning algorithm? I think people know how to do the hidden Markov chain. Now these are new techniques that are being devised. But I don't think they go away, and actually, as we've discovered, many of them are, given the information that you're put into the system, those optimization techniques work very well. Where it gets kind of interesting though is if you've got an optimization technique you've had for a period of time, you may think it's very optimal. You can find out, is it optimal, by running a machine learning algorithm on top of it. You discover it's pretty good. But what you can do is throw more data at the problem and very quickly see that maybe a machine learning algorithm can start to learn more. So I don't think those things have gone away, and they're still very valuable tools. And I think on a daily basis we're tending to blend those things, fairly well. And another part of that story, of course, is the cognitive side of it, right? So which tends to be yet another generation that people play out. So.
Any other questions? Victor?
I was wondering what obstacle pertaining to data science has anyone faced in their career, whether it be lack of resources, lack of computing, lack of funding. Yeah, one of the big pieces for us is actually delivering the insights real time to our merchants, like especially from an front end perspective. Like we were experimenting with TensorFlow and all these other things to try all those things. So that's definitely a big limitation for us in terms of how do we deliver these insights.
I think for us, a lot of organizations, but that's one too, but I think a lot of the organizations, it's plain and simple, they don't have the data in an accessible format. And so you can have all the great data scientists you want, but if you actually can't get at the data, or nobody knows where it is, or it doesn't link to the right things, they haven't been tracking the right things, that's where it's often a big limitation in terms of answering the problem you want to answer.
Just to add on that, I think the other thing is operationalization. There's a lot of data and machine learning research being stuck in early stages. Like you go experiment, you love doing it, it's so much fun, then it dies. I see this a lot. And the main reason for that is going back to business, because business never had that problem, but data scientists thought it was cool to solve, so it never went anywhere.
Data, getting access to data is one of our bugbears every day, and operationalization big issues. And another one on top of that we would face is explainability. So one of the problems with an algorithm, especially in a bank, is the deterministic algorithms, you know exactly why it did what it did, right? It's sort of like, there's a rule, you follow the rule, it gives you the answer. The problem with a lot of machine learning algorithms is you can't understand what it is that it's doing. And a regulator would look at that and say, well, you can't explain how the algorithm works, therefore you can't use it. So there's a big impediment there about unexplainable things. And, so that's where things like capsule theory becomes kind of interesting, because it helps you maybe explain why something's occurring. So explainability, once you've got the data, which is probably the 99.99% of the problem, and once you've actually got it working, which is yet another big one, then you've got that face hurdle of, well, will someone let you use it? And in a bank it's true because of regulators, but a lot of industries, health is very regulated, and a lot of other things where regulations true that will hit you. And then even just business people understanding what it is you do, that tends to be a big issue related to that as well.
One last question.
Oh, I have two questions. But the second one's really quick. Oh my gosh, there's a delay on this thing. Doesn't it drive you crazy? Okay, I'll just try not to pay attention to the echo. My first question you briefly touched on is your data analysis is only as good as the data that you have available to do. And some of the fields don't have such good data. I'm thinking in particular of data needed to support policy decisions by government for mental health and education. So I'm just wondering, and maybe because you guys have a financial business background, you don't really have a good idea on this, but how far away you think we are from having more standardized, high-quality data across all the different fields that need it? And my second question, which is the quick one, if I'm to believe social media, I can become a data scientist in 8 weeks. What are your thoughts on these programs?
Go for it. The first one, honestly, the data quality, I think it's not the data, it's the people. The people and processes in place that are avoiding us to get to that good data, or even to create the good data, right? So most of the times it's never the technology problem or the data problem, it's the people and process problem, and those problems are harder to solve. I wish there was this magical technology that is going to solve that problem, but it's actually a people problem. And there is a kind of a good book kind of around that, it's called The Silo Effect. And it actually talks about how people tend to get into silos in their personal and business lives, and that creates the data silos, and you never know where the good data is sitting. So that's a big problem. When is it going to solve? I don't know. Not next year, I can tell you that. The second one, yeah, can you become a data scientist in 8 weeks? Maybe you can. Would I hire you? Probably not. Yeah, it's actually one of my big struggles these days. Like I did get a lot of resumes taking Andrew's Coursera course, and their title is data scientist now. I'm like, ugh, I don't know about that. It's kind of about getting your hands dirty, getting real projects done, and working with data and understanding it. So I think experience is really important than just that education.
I've been thinking a bit about these whole boot camps because I think they're interesting things. Because I would agree that generally speaking, I wouldn't be going, oh yeah, I want to hire someone who's done an 8-week or 12-week course. But I do find that I was recently involved in a project defining a new program for a higher learning institution. And I realized how long the cycle is for these kind of things. Like it takes a long time to get a course approved, to move it forward. And so by the time we're going to graduate people with the skills we're talking about today, it's 4, 5, 6, 7 years before we have graduates with those skills. And so it got me thinking that there probably is a role for these types of programs to augment. So you should still do, you know, your degrees and your undergraduate with getting the basics. You should still get work experience, but you do need to learn new technology quickly. You do need to be able to attack new kinds of problems and new kinds of data. And I probably think there is a role for some of these programs. I don't know which ones are the best. I don't know, you know, but in terms of jump-starting some of those things, because it's changing so rapidly. It's really hard to keep up. And it's hard for the academic institutions to keep up too. I still think you should go to them and learn how to learn, so then you can augment with the boot camp.
So actually certificate programs are good too, and boot camps are good too. So one single thing, so I have an engineering background and my undergraduate was engineering. So if you have an engineering degree and you're taking, let's say, 60 courses, are you using all of them in your major when you're working? So if you're taking, let's say, 8 courses and doing a capstone project as well, and you're finalizing in 6 months, right? Maybe not 6 weeks, but 26 weeks, okay? So it is doable, right? But you're taking all the core material and you're taking the major courses that will be used in data science. So it is hard to compare those programs with an undergraduate level program. I understand that. Undergraduate degree is touching more base. You have some minors as well, but if you come out with an engineer, if you start your job as an engineer, are you using really all of the courses that you have seen in undergraduate? So that's why data analytics boot camps or the certificate programs or the master's programs, okay? So those are all the technical and all the major materials are there. So it's like really summarizing everything. And if you're dedicated and if you're curious, it is doable, because those courses, when you're taking those, I know my students, they're really dedicated. They're taking 3 courses, let's say, per week, but day and night they are working, they are learning programming, they are doing data science. There are many open source data sets that they can really practice their own knowledge. So it is something that we should consider, and the background is very important, how we are using our background, right? So you can ladder up things with those boot camps or certificate programs. Anything is, I think everything is good, as much as we can use them, as much as we can produce with them. I'm really excited.
Thank you. I think now, just to give people a bit of time to network and everything, we're going to close, but the panelists, I think, will be around for a few minutes. If people have more questions, please come on up. And I'd like to thank everybody for coming out today. I was hoping to announce the next seminar at this one. Unfortunately, I'm still working on a date. I have a number of people who volunteered some very exciting topics, so I'll give you that teaser. But please do sign up for the email list. Keep track of us on social, and we will be letting you know about the next seminar as soon as there's details. I'm planning to have one in either April or May of this year. So, and anyone who's got feedback for me, please feel free to reach out. We'd love to hear from people what they think. Thank you.